So in this video, we're going to be looking at my implementation of a circular linked list in Java. So here this program implements a circular linked list and has a number of functions to add, remove, view, and manipulate the data. The list is defined as following. This can change, so the definition of a circular linked list can change according to your definition, but how I'm structuring this is it's going to have a head node with a next pointer that points to the first node and a previous pointer that points to the tail. The first node has a next that points to the second node and a previous that points to the head, and a tail node with a next that points to the head and a previous that points to the second to last element. So in this circular linked list, I'm using a list node class to define all of my nodes, and I'm using Java's generics, which is the E, so that this works with any given data type. So in my list node, I have the info, so that's going to be the data that you're passing in to the list and what you ultimately want to store. Then it's going to have a next pointer and a previous pointer, which will point to the next node in the list or the previous one. The constructor, this is the default constructor, which has nothing passed in, sets everything to null, and then the constructor that has parameters has everything and sets all of the fields parameters and the field variables to the parameters. So this circular linked list class extends comparable super E. This is basically the generics for Java, again, that allows you to use any data type with the circular linked list. You can implement it with integers, with strings, with any object that you create, as long as the object that you create also extends comparable. So this class also implements myList, which is the interface that I defined here that outlines some of the common main methods that you use in a circular linked list, such as isEmpty, remove, add, front, and size. So let's look at some of the functions that I created in this list. First, the constructor sets the head to a new list node. Head.next is the head and the head.prev is the head. This is when you're creating an empty circular linked list, and therefore the size will be 0. Then we have a method called size for returning how many items are in the list, a front function that returns the data stored in the front index of the list. If it's empty, it will return null. Then there's a method called isEmpty. This tests whether the list is empty, and it will return the corresponding Boolean value. And then an add function, which will take in an object and add it to the beginning of the list, and it will create a new node with the information that you pass in and connects it to the front of the list so that it will rearrange the pointers, such as head.next.prev will now equal the new list node, and head.next also equals the new list node. And then you increment the size, because we've just added a new item. The append method creates a temporary node, adds it to the end of the list, and reworks the pointers. And officially, it adds a new item to the end of the list, and it returns nothing. So again, we do similar things. We rework the pointers, except this time it adds it to the end of the list. So insert adds a new item at any position that you pass in, and it needs nothing. It needs the item, and it returns nothing. It will also make sure that this is a valid function and there's enough existing items to make sure this position actually exists. So first it'll check if the position is greater than the size. If it is, then therefore there's not enough existing items, and it will return and cut off the rest of the code. If it is a valid position, it will iterate through the list, and if the index of the iteration is at the given position, it will insert the new node and fix the pointers. So next we have the remove method, which will remove the passed in item from the list. It needs the item and returns the item that is removed, so the same one, or null if it's not in the list. This will iterate through the array, and when the info of the node is the object, it will remove the object and fix the pointers. It will fix i.prev.next to i.next, i.next.prev. So the next one's previous to the current's previous. Basically, it's sort of mending over the one that you're removing, and then for garbage collection, it will change the pointer of the one that we're currently on to null and the previous to null, and that item will then just fall away. Then it will decrement the size as we're removing an object and return the information. This one, remove node, will remove a specific node and then return the information from that node. So you pass in the node that you want gone, it will fix the pointers, and then clear the node for data collection, garbage collection, decrement the size, and return the info of the node similarly to the previous one, except this time you're passed in a node. So the remove all function I defined as it removes all occurrences of the past an object from the list, and it returns nothing. So if it's empty, it will return nothing and nothing will happen. And then otherwise, you're going to run a while loop and check if this object is still in the list. If it's still in the list, you'll remove the first iteration of the object using the remove function we designated a couple seconds ago. And while this is true, it will continually remove the instance of the object until it's done, and then all of those occurrences of the item will then be gone. The pop function removes and returns the first item. It needs nothing and returns the item. Again, it will check if it's empty and it'll return null, and if not, it will return the remove node, so it'll pop the first node, it will remove it, and then because the remove function returns the information, it will return the information returned from the remove node function. The next one, the pop real, works similarly. You're just removing the node, and the passed node will be the tail, which you can get by head.prev because it is circularly linked. So pop removes and returns the item at position pause. It needs the position and returns the item. Again, it's sort of like the remove function. If the position is greater than the size, it returns nothing. If the position is the size, it pops the last one. Those are the special cases. And then otherwise, it will iterate through the list, and if it reaches the specified index, it will pop the value and fix the pointers. So pop, again, this is another instance of pop. It takes in an item though, and it will return the pop, so the information that the pop spits out, and then you're gonna put in the pop, you're gonna just pop because that takes in the position variable, you're going to find the position using the index of method, you will pop it and then return that. Public e-rear, so this function returns the last item in the list. It doesn't actually manipulate the values, but it will return the information if it's not empty. Index of returns the position of the item in the list. It needs the item and returns the index, or -1 if it's not in the list. So it will iterate through the array, and then it will compare the object to the info of the current specified index, and then turn the counter, and if there's no item in the list, it will return -1. So indices of returns a list of the positions of all occurrences of the item in the list, and it needs the item, and it will return an array list. So it will first create the array list, and then it will iterate through the array and return the index at the given spot, again using the counter as the index. So value at returns the item at a specified position in the list. It needs the position, returns the value, and makes sure that the position is valid. First it checks if the position is greater than the size, it will say it's not valid and return nothing, and or return null rather. Otherwise it will iterate through the list and check if the index is at the position. It will return the information at that node. Otherwise it will increment the counter and increment the node. So find searches for the item in the list and returns the item. So it will make sure that it's sort of like it will iterate through the list, and if the object is equal to the item, it will return true. So contains returns a boolean based on whether the item passed in is in the list or not. It will iterate through the list and check against each node to see if the object is equal to the list. At the very end, if it's equal to the current node, it will return true, and at the very end, if nothing has returned true, will return false. So the toString method will return a string of the circular linked list's data from first to last, and it will include the square brackets and the commas according to the Java format. And then the reverse toString will do the same thing, except it will reverse it and run through it backwards, again using the square brackets and the commas according to Java formatting. So yeah, this was the circular linked list implementation. Circular linked lists are very good for problems that are inherently circular, such as maybe you want to represent a Monopoly board using code. As you know, the Monopoly board is around a circle, so you go around the edges of the board, or maybe this is just an easier way to store, add, and manipulate data.